In this video, we're going to take a look at some more questions with imaginary solutions and roots. So example 1 says solve x squared plus 16 equals 0. So I know that normally when I go to solve a quadratic equation or an x squared, I have two main options. I can either factor or I can solve with the quadratic formula where I identify a, b, and c. If I try to factor this, there's no GCF. It has two terms, so it either has to be dots, difference of two perfect squares, or SOAP, difference or sum of two perfect cubes. It doesn't fit either of that criteria because it is the sum of two perfect squares, and I can't factor that. So I could identify A, B, and C and use the quadratic formula. But what you might notice is that I can use a shortcut here. I can isolate my x squared by subtracting 16 on both sides. And then I can square root each side. And I get x on the left side. On the right side, whenever you square root, you always get a plus and a minus. And you should know that the square root of negative 16 is 4i. If you don't, you can use your calculator. On the home screen of your calculator, second square root, negative 16, and as long as you are in the correct mode, which you should be from previous lessons, your answer will be 4i. So here is my answer to example 1. Examples 2 and 3 are going to focus on some multiple choice strategies. Which equation has imaginary roots? So hopefully you remember that imaginary roots means there are no x-intercepts. So I'm going to type each equation into y equals and look at the graph. So I have y equals, if you have anything there, clear it out. We have x squared minus 2x plus 1. Going to hit graph. Remember, if when you hit graph, you have a weird window, zoom 6 always brings you back to that original window. I have an x-intercept, so choice 1 can get crossed off. That's not my answer. Going back to y equals, x squared minus 2x minus 1 this time. Hit my graph. This time I have x-intercepts again, so choice 2 can get crossed off. That's not my answer either. Go back to my calculator, go back to my y equals, x squared minus 2x plus 5 this time. Hit my graph. And as you can see, there are no x-intercepts here, so my answer should be choice 3. If you want to be sure, you could just check out choice 4 to confirm. It would be a minus 5, and if I hit the graph there, I have x-intercepts, so it is not choice 4. Example 3, the roots of the equation x squared plus 2x plus 5 equals 0 are, remember, roots are solutions or zeros or x-intercepts. So notice how choices 1 and 2 are real solutions, and 3 and 4 are imaginary or complex solutions. So the first thing I want to do is use my graph to eliminate answer choices. So y equals x squared plus 2x plus 5. X squared plus 2x plus 5. I'm going to hit my graph. So I have no x-intercepts. So no x-intercepts means that I have to have imaginary solutions. So I'm going to cross off choices 1 and 2. Now, choices 3 and 4 are imaginary. I don't know which it is. I could identify A, B, and C and solve using the quadratic formula, but because it's multiple choice, I can use a multiple choice strategy by plugging in my answers for x. So I'm going to start with choice 3. X equals -1 plus 2i. You could use -1 minus 2i, it doesn't matter, but if one of them works, the other one does. And my equation is x squared plus 2x plus 5 equals 0. So I'm going to substitute in, instead of x, I'm going to put in -1 plus 2i every time I see an x. And hopefully it equals 0. So I'm going to go to my calculator. I am going to go to the home screen and I'm going to substitute. -1 plus 2i, remember second decimal point gives you the I, squared, plus 2 times -1 plus 2i plus 5. And we get 0. So that means choice 3 is my answer. Now, if you want to check choice 4 just to make sure that it doesn't work, I can actually scroll back up. Once it's highlighted, I can hit enter and it copies and pastes it for me. So choice 4, instead of -1 plus 2i, would be -1 plus 4i. So I can change my 2i's to be 4i's. And I get -12, which does not equal 0. It confirms that choice 3 should have been my solution.